professor at LG Institute of Engineering and Technology. Today we are going to study a very important chapter, that is Laplace transform. So let's begin with the definition of Laplace transform. If f of t is a function of t defined for all t greater or equal to 0, then integration 0 to infinite e raised to minus st f of t dt is defined by Laplace transform of f of t, provided the integral exists and it is denoted by Laplace transform of f of t. Okay, so the definition of Laplace transform is, we will denote it by this symbol, and it is integration 0 to infinite e raised to minus st ft dt. Okay, so this is the main formula to find the Laplace transform. Now the integral is a function of s and it is denoted by fs. Okay, so after solving this integration you will get a function of s. Okay, and we will denote it by f of s, or we can say f bar of s, or we can say phi of s also. Okay, now let's study sufficient condition for existence of Laplace transform. First one is f of t must be a piecewise continuous function. Okay, that is f of t must be continuous in every subinterval and f of t must have finite limit at the end points of each subinterval. Okay, now the second point is f of t must be exponential order. Okay, that is if limit t tends to infinite e raised to minus alpha t f of t, it should be a finite number. Okay, and let's see example. So if we want to find the Laplace transform of 10t, this does not exist. Why? Because 10t is not a piecewise continuous function. Okay, so similarly Laplace transform of sec t, cos sec t, cot t, this does not exist. Now Laplace transform of e raised to t square also does not exist, because e raised to t square is not of any exponential order. Okay, now let's study some basic properties of Laplace transform. First one is linearity. So if Laplace transform of f1t is f1 of s and Laplace transform of f2 of t is f2 of s, then Laplace transform of a f1t plus b f2t is what? A f1 plus b f2. Okay, so we can split the Laplace transform, okay, where a and b are some constant. Now let's see its proof. Laplace transform of ft, this is the main formula, that is integration 0 to infinite e raised to minus st ft dt. Okay, now Laplace transform of ft, integration 0 to infinite. Now e raised to minus st as it is. Now in place of ft we will write a f1t plus b f2t dt. Okay, now what we will do, we will multiply this e raised to minus st inside. Okay, and we will split the integration. This a and b are constant, so we will take it outside the integration. So here you will get a times integration 0 to infinite e raised to minus st f1t dt plus b integration 0 to infinite e raised to minus st f2t dt. Okay, now from this, so from the definition we can say that this is the Laplace transform of f1 of s and this is the Laplace transform of f2s. Okay, so we can write it like this, that is af1s plus bf2s. Okay, so this linearity property is proved. Okay, now let's find the Laplace transform of elementary function. The first one is f of t is equal to 1. Okay, so firstly we will write the main formula, that is Laplace transform of ft is integration 0 to infinite e raised to minus st ft dt. Now main thing starts from here. Okay, so 0 to infinite e raised to minus st. Now here the function is given 1, so in place of f of t we will write 1, so here 1 dt. Now just integrate this with respect to t. So what you will get, e raised to minus st upon minus s, and the limits are 0 to infinite. Okay, now substitute the limit, and before that we will keep this minus 1 upon s outside. Okay, so here we will get e raised to minus infinite minus, now lower limit here will get e raised to 0. Okay, simplify this, so we'll get minus 1 upon s, e raised to minus infinite is 0, so 0 minus 1, simplify this, so you will get answer 1 upon s. So Laplace transform of 1 is what? 1 upon s. So this is a formula. You have to remember it as a formula. Okay. Now next we will find the Laplace transform of ft is equal to t raised to n, right? So again first we will write the formula. So Laplace transform of ft is equal to integration 0 to infinite e raised to minus st ft dt. Correct. Now integration 0 to infinite e raised to minus st. Now in place of ft we will write t raised to n dt. Okay. Now what we will do, we will suppose this st as x. Correct. From this what you will get, t is equal to what, x upon s, right? So dt is equal to what, dx upon s, right? Now as we are changing the variable, we will change the limit also. Okay, now this is the limit of t. So as t tends to 0, this x tends to 0. Okay, from here as t will go to 0, this x will go to 0, and if t tends to infinite, then x tends to infinite. Correct. Now this is the integration 0 to infinite e raised to minus, now in place of st we will write minus x. Okay, in place of t we will write x upon s whole raised to n, and in place of dt we will write dx upon s. Okay, now here the integration is in the terms of x. Okay, so this s is constant, so s raised to n, and this another s we will take it outside, so it is 1 upon s raised to n plus 1. Okay, integration 0 to infinite e raised to minus x into x raised to n dx. Now this integration is a gamma function formula. Okay, this we have already studied in semester 1. So this is gamma n plus 1 upon s raised to n plus 1. So Laplace transform of t raised to n is what, gamma n plus 1 upon s raised to n plus 1. Now if this n is a natural number, okay, then we know from the property of a gamma function that this gamma n plus 1 is what, n factorial. Okay, so Laplace transform of t raised to n for a natural number will be n factorial upon s raised to n plus 1. Okay, so we have to remember two formula over here. If n is a natural number, then we will use this formula to find the Laplace transform of t raised to n. Okay, and for any n we can use this formula. T raised to n is what, gamma n plus 1 upon s raised to n plus 1. Correct. Now let's find the Laplace transform of another function, that is e raised to 8. Okay, so Laplace transform of again ft is what, integration 0 to infinite e raised to minus st ft dt. Correct. Now function is e raised to t, so integration 0 to infinite e raised to minus st into e raised to at dt. Now to solve this integration, what we will do, we will write like this, e raised to minus take common, so s minus a into t dt, right? Now just integrate it, so what we'll get, e raised to minus s minus at upon minus s minus a. Okay, and the limits are 0 to infinite. Okay, now again this minus 1 upon s minus a we will take outside. Okay, and just apply the limit. So here e raised to minus infinite minus e raised to 0. Okay, now this e raised to minus infinite is 0, so from here we'll get 1 upon s minus a, this is 0 minus 1. Simplify this, so it will give you 1 upon s minus a. Therefore Laplace transform of e raised to at is what, 1 upon s minus a. Okay, so this is again a formula which we have to remember. Now the next is Laplace transform of this e raised to minus at. Now as we have solved the Laplace transform of e raised to at, similarly we can solve the Laplace transform of e raised to minus at. So you will get the answer of e raised to minus at as 1 upon s plus a. Okay, so again this we have to remember as a formula. You can prove this formula as we have solved this e raised to at. Correct. Now let's solve one another. So Laplace transform of again main formula is integration 0 to infinite e raised to minus st ft dt. Okay, now your function is what, sin 80. So integration 0 to infinite e raised to minus st sine 80 dt. Okay, now to solve this integration we have one formula, that is e raised to ax sine bx dx. Okay, we know this formula. Answer is e raised to ax upon a square plus b square a sine bx. Okay, and here we have minus b cos bx. We have a formula for e raised to ax cos bx. Okay, and that is e raised to ax upon a square plus b square a cos bx plus b sin bx. Okay, so this formula we have to remember to simplify this integration. So now on comparing this, we can say that this a is minus s and in place of b we have a. Okay, so integration will be e raised to minus st upon s square plus a square. Okay, and here minus s sin 80 minus, and here we have a cos 80. Correct? We have used this formula to simplify this integration. Okay, now just in place of a we have to write minus s, and in place of b we have to write a. Limits are 0 to infinite. Okay, now just substitute the limit. So again e raised to minus infinite, it will give you 0, so upper limit is directly 0, minus now lower limit e raised to 0 is 1. So here we have 1 upon s square plus a square. Okay, now we know sine 0 is 0. So this term is 0 and cos 0 is 1. So we have minus a. Okay, just simplify this. So you will get answer as a upon s square plus a square. Right? So Laplace transform of sine 80 is what? A upon s square plus a square. Okay, now we'll find the Laplace transform of cos 80. Okay, so as we have solved for sine 80, we can similarly solve for cos 80. Okay, we have to use the formula, this integration e raised to ax cos bx, which I have already written. Okay, apply this formula and simplify, so you will get the Laplace transform of cos 80 as s upon s square plus a square. Okay, again you have to remember this formula to solve the example. Now next one is Laplace transform of cos hat. Okay, now again we'll use the main formula for Laplace transform, that is integration 0 to infinite e raised to minus st ft dt. Okay, now integration 0 to infinite e raised to minus st. Now function is cos hat, so here we have cos hat dt. Now we know that this cos hat is what? E raised to 80 plus e raised to minus 80 upon 2, right? So just we have to simplify this and then we have to integrate it. Okay, take this 1 by 2 outside. Here integration 0 to infinite e raised to minus st into e raised to 80 dt plus 1 by 2 integration 0 to infinite e raised to minus st e raised to minus 80 dt. And now this is similar to e raised to 80. Okay, so we'll quickly solve this. E raised to, again take minus common, here we have s minus 80 dt plus 1 by 2 integration 0 to infinite e raised to minus, here we have s plus 80 dt. Okay, integrated, so here we'll get e raised to minus s minus a upon s minus a. Okay, plus 1 by 2 minus, here we have minus. Okay, and the limits are 0 to infinite. Then again e raised to minus s plus 8t upon minus s plus a. Okay, our limits are 0 to infinite. Substitute, take this 1 by 2 outside. Okay, substitute the limit, so e raised to minus infinite is 0. Okay, so here we'll get 0 minus, now minus minus will become plus and e raised to 0 is 1, so 1 upon s minus a plus, now here e raised to minus infinite is again 0, minus minus will become plus, so here we have 1 upon s plus a. So 1 by 2, simplify this, so s plus a plus s minus a upon s square minus a square. Correct? Okay, so this a will get cancelled. So what remains is 1 upon 2. Here 2s upon s square minus a square. 2 will get cancelled. So final answer is s upon s square minus a square. So Laplace transform of cos hat is what? S upon s square minus a square. Right? Now, next we have to find the Laplace transform of sin hat. Now we know that sin hat is what? E raised to at minus e raised to minus at upon 2. We have to solve similarly, okay, and on simplification what you will get? Laplace transform of sin hat as a upon s square minus a square. Okay, so this is again a formula which we have to remember. Okay, now let's solve examples. So the question is, find Laplace transform of f of t, and the function is given in this way. It is 0 in between 0 to pi and sin t for t greater than pi. So firstly we will apply the main formula, that is Laplace transform of ft is integration 0 to infinite e raised to minus st ft dt. Okay, now as you can see in the question, it is divided in two parts. So we will divide the integration in two parts, that is integration 0 to pi plus integration pi to infinite, correct? Now in the interval 0 to pi, the value of function is 0, so this integration is 0. Okay, and if for t greater than pi we have sin t. So here we have e raised to minus st into sin t dt. Okay, so we need to simplify only this portion. So integration pi to infinite e raised to minus st sin t dt. Okay, now again we have to use the e raised to ax sin bx formula. Okay, so from that we will get e raised to minus st upon s square plus 1. Now coefficient of here t is what? 1, so here we'll get 1 square, that is 1. Now minus s sin t minus, here we have 1, so we'll write just cos t, and the limits are pi to infinite. Substitute the limit, so e raised to minus infinite is 0, so upper limit is 0 minus, now substitute the lower limit. So here we'll get e raised to minus s pi, in place of t just substitute pi, okay, upon s square plus 1. Now we know sin pi is 0, so this term is gone, this is 0. Cos pi is minus 1, so minus minus it will become plus, so here we have plus 1, right? Now just simplify this, so what we will get? Minus e raised to minus s pi upon s square plus 1. So this is the Laplace transform of ft, that is the given question, right? So in this way we can find the Laplace transform. Okay, so the next question is, find Laplace transform of sin 2t sin 3t. Okay, now this we have to find Laplace transform of sin 2t sin 3t. Okay, so what we'll do, we will multiply and divide it by 2. So 1 by 2 Laplace transform of 2 sin 2t sin 3t. Okay, now we have to use the formula for 2ss. Okay, so 2ss is what? Minus c plus c. Okay, in the first c we have to add, in the second we have to subtract. So this is 1 by 2 Laplace transform of cos. Add them. So 2t plus 3t, it will give you 5t. Okay, here we have negative sign plus, and from here we will get cos. Now 2t minus 3t, it will give you minus t, but the cos is even function, so we will get only t, right? Now we know the linearity property. Okay, so we can split the Laplace transform, right? So just simplify this and write down the Laplace transform. Now we know that Laplace transform of cos at is what? Laplace transform of cos at is s upon s square plus a square, right? So we will use this formula, minus sign, as it is here a is 5, so s upon s square plus 25. Okay, plus, now here a is 1, so we'll use s upon s square plus 1. So this is the final answer. Okay, so we can directly use this formula to simplify this type of questions. Okay, now let's solve one more example. Laplace transform of 4t square plus e raised to 2t. Okay, now we'll take 4 outside. Laplace transform of t square plus Laplace transform of e raised to 2t. Okay, now we know Laplace transform of t raised to n is what? N factorial upon s raised to n plus 1 if n is a natural number. Now here we have 2. Okay, so in place of n we have to write 2. Okay, so what you will get 4 as it is here, 2 factorial upon s raised to 2 plus 1, it will give you 3. Okay, plus now we know Laplace transform of e raised to at. It is 1 upon s minus a. Okay, so from here we'll get 1 upon s minus 2. Just simplify this. So here 2 factorial is 2. So 8 upon s cube plus 1 upon s minus 2. This is your final answer. Okay. Okay. So in this way we will use the formula which we have proved today to solve the example. So I hope you have understood. Thank you for watching.